Hello everyone, welcome to the IGCSE Physics predictions for May 2026 paper 1 video. So this is going to be a long one, so please bear with me till the very end. I will highly recommend you watch this video as well, IGCSE Physics full paper 1 revision, and the link is given in the description. In this video I have covered every concept in like extreme and extensive details, very comprehensively. This will be very useful. Make sure you have gone through this video. Also, what I've been noticing over the years is students making some really common mistakes in paper 1 and 2 combined. So what I've done also is I made another video on common mistakes to avoid in IGCSE physics. Watch this as well. This will be very beneficial for you as well. Also, this is the most important one. I have compiled all the frequently asked questions of paper 1 and paper 2 um, combined. And for paper 1, you'll only be revising the answers in not bold fonts, okay, in the non-bold fonts. The bold answers are only for paper 2, right? And this is updated for 2026 session. With this, you'll get a free definition sheet, and I can promise you, you'll get a lot of definitions common from here and a lot of answers because IGCSE is very repetitive. And also, this took me over a month to make a free experiment sheet with the fact sheet. So please download this. This will be very beneficial for your exam tomorrow. Now let's get started. So these are the 8 units from which you'll be asked questions. So I'll be referring to the units, all right, in my video from this point onward. Unit 1 is forces and motion. Unit 2 is electricity. 3 is waves. 4 is energy, resources, and energy transfers. But, okay, let me tell you. Give me 1 second. 5 is solids, liquids, and gases. 6 is magnetism and electromagnetism. 7 is radioactivity and particles. And 8 is astrophysics. This part. So these are the units of both paper 1 and paper 2 combined. But you know what? There are some topics that are not in paper 1. So when you are revising for your exam tomorrow for paper 1, you can literally just leave out these topics because you won't be needing them for your exam tomorrow. So one is momentum, Newton's third law, moment, static electricity, sound waves with oscilloscope, energy resources, right? So even though it says energy resources in 4, you'll be only asked questions regarding energy transfers, not energy resources. State change and specific heat capacity, electromagnets, forces on moving charged particles, transformers, the brightness of stars, apparent magnitude and absolute magnitude, HR diagrams, redshift calculations, and conclusions. All of these are literally for paper 2, not for paper 1. You can leave out all of this. And rest assured, these are not coming in your exam tomorrow. Focus on the rest. Next. So let's look at the predictions for paper 1. Let's start with unit 1. Okay. So you need to be able to identify forces. For example, there are 4 forces over here. This is the forward force. You can also call this thrust, the 3001. This is 1000 Newton. This could be drag, resistive force, opposing force, friction, right? The upward is the reaction force, normal reaction force from the tires in contact with the ground. And of course, vertically downward is always the weight. So this is just in one scenario. There could be any other scenario where you have to identify the forces and calculate the resultant force. Check this out. There is only a resultant force in the horizontal direction, as in 3000 minus 1000. There is no resultant force in the vertical direction. And for calculating acceleration, just use the equation F equals ma. Then in unit 1, factors affecting thinking distance and braking distance. This is a very important concept. Please make sure you go through this. Then calculation of stopping distance from the graph. Okay, so I hope you know how to calculate the stopping distance. Any distance from a velocity time graph is the area under the graph. Okay, then you have a very common concept of terminal velocity. Okay, so let me give you a heads up right now. Here, I am only discussing the topics that are most likely to appear in the exam. I'm not discussing any topic per se. Okay, for the discussion, you can refer to the full syllabus revision, but after watching this, because these are the topics you need to mainly focus on. So you see, the skydiver initially accelerates, then reaches a terminal velocity. This is where the skydiver opens his parachute and the velocity decreases and then reaches the terminal velocity for the second time. So generally what they do is they give these two graphs separately, and at times they can come together as well. Okay. So remember, here the skydiver is accelerating this part. This is constant speed, and this part, this is deceleration. And again, a second terminal velocity, which is a constant velocity. You need to be able to link this with forces. Okay, when does a body accelerate and when does a body decelerate? Okay, a body accelerates only when the resultant force acts in the same direction as the motion. A body decelerates when the resultant force acts in the opposite direction to the motion. Okay, now this part is really important. Motion graphs. So for motion graphs, you need to be able to analyze distance time graph as well as velocity time graph. So I have curated these two concepts very carefully. So let's see. Always remember, when it comes to a distance time graph, the gradient of distance time graph gives me velocity. So you can see it's a straight line, right? And we all know straight lines have a constant gradient. And since the gradient of distance time graph gives velocity, a constant gradient will give you a constant velocity. But you get the same shape, but for a velocity time graph. This time you cannot call it constant velocity because the gradient of velocity time graph gives you acceleration. Since it's a straight line, the gradient is constant. That means the acceleration is constant. And a horizontal line in the distance time graph means that the distance is not changing, as in the body is stationary. Whereas a horizontal line in the velocity time graph means the speed is constant. And a curved graph upward means acceleration. Why? Because a curved graph sloping upward means the gradient is increasing. Guess what? Gradient of distance time graph gives me velocity. And if the gradient is increasing, the velocity is also increasing. And guess what? Increasing velocity. The other name for increasing velocity is acceleration. And the same concept applies to a curve that is sloping downward, right? Gradient is decreasing, velocity is decreasing, and the other name for velocity decreasing is deceleration. Let's move on. Okay. So use the graph to show that the distance traveled by the surface of the liquid is 4.7 centimeter. So the question says distance traveled, right? And when it comes to a velocity time graph, we all know that the area under the graph gives you the distance traveled. And this looks like a very straightforward right angle triangle. So the area under the right angle triangle is half into base into height. But look at this graph. This is also a velocity time graph. Part A says by drawing a tangent to the graph, determine the acceleration of the car at time of 20 seconds. So you go to the time of 20 seconds and you draw a tangent over here. The rule of drawing a tangent is it should touch the graph only at one point. So this is how you draw your tangent. And now extend this. Right? So now you find out the gradient of this triangle, which will give you the acceleration at this specific point. And since the graph is curved, it is very obvious that the acceleration is not constant. The acceleration is changing. Now comes the moment of truth for part B. It says determine the distance traveled with the car during the first 80 seconds of the journey. So you see first 80 seconds, right? Now, this is very, very, very important. Bear with me. So this is your velocity time graph. Always remember the area under the velocity time graph gives you the distance traveled. But look at the shape. This is not any a specific geometric shape. Had this been a right angle triangle like this, you could have easily calculated the area under the graph. But look at this. You cannot directly calculate the area under this graph using trigonometric equations. So this is when you have to apply the concept of square counting. Okay, let me show you how square counting works. And I repeat, square counting you only apply when you don't have a perfect geometric shape. When you have an irregular shape like this is when you apply the square counting. This is not an easy concept, and I've seen a lot of my students struggle with this. Check this out. So the very first step is to count the number of complete squares. 1, 2, 3, 4, 5, 6. Okay, so you only have 6 complete squares. Then, this is the craziest part. You take bits and pieces of the incomplete squares and you connect them to make complete square. For example, you have one small piece here and one small piece missing, right? So you take this and place it over here, and that what's make this square number 7. Then, um, let's say you have this part in the graph and you have this part missing from the graph. So you take this and place it over here. That's what makes your square number 8. Then, um, let's say you take these two positions and you place it over here. Okay, that will make your square number 9. And if you look very closely, this is the craziest part, as I've been saying. This part, if you place it over here, will make it 1/4 of a complete square. So this could be 9.25. Okay, so now you have 9.25 or 9.5 is also fine. Don't worry about it. So there is always a range for this type of questions. The next thing is the most important part. You find out the area of one square. You find out the area of one square and keeping in mind the units. Okay, this is meter per second, this is second. So find out the area of one square and multiply the area of one square with the number of squares. And that will give you the total distance. By the way, this is just one situation where you are applying the square counting method. This can be, uh, this can come in any other scenario other than velocity time graph as well. So this is how you calculate the area under an irregular shape, irregular graph. Okay, count the number of squares under the graph and multiply the number of squares with the area of one square. There you go. Fine. Now we have forces and shape. This is also in Unit 1. Sketch a graph to show that the spring obeys Hooke's law as it is stretched. You should label both axes with appropriate physical quantities. Okay, so if it obeys Hooke's law says that force is directly proportional to the extension. And if it obeys Hooke's law, the shape of the graph is a straight line through the origin. Next, state how the graph shows that rubber band does not obey Hooke's law. For 1 mark, it's very obvious that it is not a straight line. Okay, for Hooke's law, the graph should be a straight line to the origin. It does go to the origin, but it's not a straight line. And next it says, explain how the graph shows that the rubber band is elastic. See, when you load the graph, load the spring, sorry, load the rubber band, my bad. When you load the rubber band, as in apply forces, and unloading is removing the forces. And when you remove the force, you see it goes back to the original shape. So that is the definition of elastic. When the force is removed, the rubber band goes back to the original shape or original position. Or when force is 0, the extension is also 0. Now we move on to Unit 2, as in electricity. So the first topic is investigation of how current in a filament lamp, this is a filament lamp, varies with voltage. Okay, so the focus you have to put on is on the word varies. Student has this equipment: filament lamp, cell, variable resistor, ammeter, voltmeter, connecting wires. Draw a circuit diagram, and this is the circuit diagram. Guess what? The question says how current in a filament lamp varies with voltage. Guess what? If the question had asked about any other component other than filament lamp, then all you had to do was just replace the filament lamp with other component. That's it. This could be a diode, this could be any other component. And why do I need a variable resistor here? Because I have to vary the current through it and the voltage across it. And the way to do that is using a variable resistor. So you need to know the shape of the graphs. Okay, for an ohmic conductor, as in a conductor that has a constant resistance because the temperature remains constant. For an ohmic conductor, the IV graph is a straight line to the origin. For a filament bulb, it is a curved graph. For a diode, there is a threshold PD. Okay, it requires a minimum voltage for it to conduct, and after the threshold PD, the current increases drastically. For the filament bulb, what you can remember, the way to remember the shape of the graph is a large increase in voltage only causes a small increase in current. A large increase in voltage only causes a small increase in current. Check this out. You increases voltage by this amount, but the current only increased to this amount. And that's because the resistance does not remain constant in a filament bulb. As you increase the potential difference, as in voltage, the resistance also increases. And this is the shape for an IV graph for an ohmic conductor. The question might ask you if it's a short, thick wear or a long, thin wear, how would this graph change? So this is where you have to recall the concept of how resistance varies with length and cross-sectional area. Then these two graphs, but the trigger is different. When it comes to an LDR, it's resistance against light intensity, because the resistance of an LDR depends on light intensity. But when it comes to a thermistor, the resistance depends on temperature. And both of these concepts have an inverse relationship. As light intensity increases, the resistance decreases, and as temperature increases, the resistance of the thermistor decreases, and vice versa. Okay, so there are some very important concepts in Unit 2 as well. Those are, let's say, when you have one single resistor and when you connect two resistors in series, what happens to the total resistance? And when you connect an identical resistor in parallel with this one, what happens to the total resistance? This is a very important concept that has been visit regularly appearing in your actual exams. Okay, so when you add resistors in series, the total resistance increases. In fact, if this is an identical resistor, the total resistance would double. But when you connect them in parallel, the total resistance decreases. And if it's an identical resistor, the total resistance is halved compared to just one resistor. So let's say if, let me actually show this with numbers. Let's say if this is 100 ohm, for these two combined, the total resistance would be 200 ohm. And guess what? When you connect them in parallel, the total resistance is halved, half that of one single resistor. So one resistor had a resistance of 100. When you connect them in parallel, the total resistance would be half of one, that is 50 ohm. Also, you need to know how to calculate the total current using V equals to IR in the calculations, very important. Recognizing how voltage is shared in components in series and stays same in parallel. For example, if this were a 6-volt battery, and if this is R and R, the 6 would get split in two parts. This would get 3, this would get 3. But if the same 6 volt is connected in parallel with these two resistors, they would both get 6 volt. Okay, stays the same in parallel. Recognizing how current stays the same in series and splits in junction. So let's say if this is 1 ampere, okay, it flows and arrives at the junction, and this is where it gets split. And if these two are identical resistors, 1 ampere will get split into equal parts. This is 0.5 and this is 0.5. But let's say if this is um, just arbitrarily, okay? Let's say this is 1 ampere. Of course, this is not 1 ampere. The value would be much smaller. The value is actually 0.03. This is just an arbitrary value to make you understand. If this is 1 ampere, the same 1 ampere will flow through all the components. And also, this is not 1 ampere. This is just an arbitrary value. Don't get confused. Next, recognizing how current stays same in series, which we just covered. How adding resistors in series affect the total resistance. We just covered this. When you add resistors in series, the total resistance increases. Then how adding resistors in parallel affect the total resistance. When you add identical resistors in parallel, the total resistance decreases. Now, using energy, okay, equation for energy is VIT. But I have seen in some papers that you have to find out the energy using charge and voltage. So then the equation becomes E equals to QV. And let me show you how E equals to QV comes. This is very common. E equals VIT. Now I want you to focus on IT part. You know Q equals IT. So instead of IT, you can write Q and then just place V. So this is how E equals to QV. Then using Q equals to IT to calculate the charge, using P equals to VI to calculate the power. Please make sure you have all of the equations memorized. Equations are given at the end of each question paper. And yes, you will be provided with equations in your actual exam. Then, in the mains electricity part, explain why the power supply is completely covered in plastic. Why is it covered in plastic? Because plastic is an insulator. It is doubly insulated so that the user doesn't get an electric shock. Then they might ask you from mains electricity, explain the advantages of using a circuit breaker rather than a fuse. So circuit breakers work much faster than a fuse in cutting off the circuit. Also, they are resettable. They don't need to be replaced, unlike fuses. Okay, this is really important. Let's say you have a voltmeter across the resistor. This could be across the LDR as well. Okay, just for simplicity, I'm placing it across the resistor. And then you have another voltmeter across this resistor. Okay, so this is actually a very common concept in IGCSE physics. Let's separate these two because this is for an LDR, this is for a thermistor. The trigger for LDR is light intensity and the trigger for thermistor is temperature. So as light intensity, let's say, increases, okay, we all know when it comes to LDRs, when light intensity increases, the resistance decreases. And this is the craziest part. When it comes to a series circuit, okay, the total voltage is shared according to the ratio of resistance. Let me make this simpler. The component that has a higher resistance will get a larger voltage, and the component which has a lower resistance will get a smaller proportion of the voltage. So if the resistance decreases, the voltage across the LDR will also decrease. But the total voltage remains same. Guess what? If the voltage across the LDR decreases, voltage across the resistor would increase. So the voltmeter reading increases. there is another way of answering this. Let me show that here as well. So let's say when it comes to a thermistor, and you know the trigger for thermistor is temperature. If the temperature increases, the question can ask you with decreasing temperature as well, but this is just for simplicity. If the temperature increases, the resistance of the thermistor decreases. If the resistance decreases, like I said, this is another way of answering this. Current in the circuit increases. And if this increased current flows through this one, the resistance of this resistor is constant, right? So according to V equals IR, its resistance is constant, but if the current through it increases, the voltage across it will also increase. This is another way of answering this. So I gave this question in one of my tests or mocks, and I saw everybody messing this up. Now, the filament lamp is connected in a circuit with a switch and a battery of 3 cells. So you need to understand the difference between a battery and cell. A battery is a collection of cells. So this is cell number 1, cell number 2, cell number 3. Okay. So let's say I remember question said each cell has a voltage of 1.5. This is 1.5. This is 1.5. Guess what? If each cell has a voltage of 1.5, the voltage across the battery is not 1.5. It is the addition of these three. 1.5 plus 1.5 plus 1.5 gives you 4.5. So the voltage that the battery supplies is actually 4.5, not 1.5. So you need to understand the difference between cell and battery. This question came only once. So this might be, important for your exam tomorrow. Next up, they can ask you to determine the fuse rating experimentally, use of earth wire, where it is connected, and how it provides safety. So always remember, earth wire is connected to the metal part of the casing. And when the appliance develops a fault, then and only then the earth wire comes into play. It provides a low resistance path for the current to flow to the ground. And how does an earth wire and a fuse provide safety? And when the appliance develops a fault, as in when the appliance becomes live, a large current flows to the earth wire. And this causes the wire in the fuse to melt because of the heating effect of current. And this is how earth wire and fuse combinedly provide safety. And then you might be asked that what are the advantages of parallel circuits over series circuits? So if one component fails, the entire circuit does not fail, and you can give individual control with parallel circuits. The purpose of a diode and its practical use. Okay, so you know that diode allows current to flow in one direction only. But what could be a practical use? A practical use could be converting AC into DC. Okay, so you know in AC current changes its direction continuously, but when you connect a diode with an AC power supply, what it does is it restricts the flow of current in both directions. Okay, and turns it into DC. Now we move on to unit 3, that is waves. So very likely you'll be asked questions about refraction, refractive index calculation. I hope you all know refractive index is n equals sine I by sine R. So this is what you use. And for critical angle calculation, you use n equals 1 by sine C, where C is the critical angle. Then you might be asked to evaluate whether a light will undergo total internal reflection. Okay? And then with ray diagrams, always remember you give arrows with ray diagrams. And you might be asked questions regarding Doppler effect. Always remember these common points that when the source is moving away from the observer, something happens, and what happens when the source is moving towards the observer. All of these are very, very, very uh, detailed, written in very extreme details in the fact sheet. Go through it. And uses and harmful effects. There is a whole different section in my fact sheet with uses and harmful effects of electromagnetic spectrum. This is very important. And for waves, the most important equation is V equals to F lambda. Very likely you'll be asked a question where you have to apply V equals to F lambda. And in May 2023, this was the very first time they asked a question where you had to draw ray diagrams using wave fronts. Okay, so remember this. They haven't asked a question regarding this ever since. So this might be important. Now we move on to Unit 4. So when you look at the book, it says energy resources and energy uh, transfers, but you don't need energy resources for paper 1. Energy resources is only a topic for paper 2, right? So when it comes to energy stores and transfers, these are the energy stores: chemical store, kinetic store, gravitational, elastic, thermal, magnetic, electrostatic, and nuclear. These are the energy stores. And energy can be transferred from one store to the other in the following ways. One is mechanically, electrically, heating, and finally by radiation. So you need to be able to distinguish the difference between energy stores and energy transfers. Then applying principle of conservation of energy. When it comes to principle of conservation of energy, always remember the total energy always remains constant. Energy is only transferred from one form to another. And when it comes to efficiency calculation, it is the useful energy output by total energy output. And in Sankey diagrams, always remember the length of the arrow doesn't matter. You always represent the straight arrow. Of course, this has to be drawn with a ruler using the useful energy, and the curved arrow represents the wasted energy. And this part represents the total input. Then process of energy transfer by conduction, convection, and radiation. Very important for your exam, very clearly given in the fact sheet as well. And applying convection in everyday situations, such as a room heater. Okay, so you need to remember the points for convection. What happens is, let's say if this is a room and you place a heater over here, this is a heater. The heater heats up the air around it. The warm air expands, becomes less dense, and rises, and the cold air replaces it. The process repeats and a convection current is set up. These are the most common points for convection. Then you have manometer and barometer. Go through this, and if I had to draw a similarity between these two concepts, completely different regardless, it would be based on the concept of pressure difference. And always remember, pressure difference is given by H rho G. And this is the pressure difference here, and this is the pressure difference here. Again, all of this explained in great details in the full syllabus revision video. Go through this. This might be very important for your exam. And then some other very important points for Unit 5 would be calculate the density using the equation density equals mass by volume. Determine the density or volume of an irregular object using displacement method. Recall the different equations for pressure in solids and liquids. For pressure in solids, the equation is pressure equals force per unit area, and this area is always the area of contact. And when it comes to liquids, Pearson calls it the pressure difference, and the equation is pressure difference equals H rho G, where H is the depth, never call it height. Recall how pressure varies with area for solids and how it varies with depth for liquids. Okay, so let's say pressure equals force per unit area. This is for solids. If the force remains the same, if area increases, pressure decreases, and pressure difference equals H rho G. If the depth increases, pressure increases for liquids. Recall how a gas exerts pressure on the walls of the container. This is a very important question. And then you have arrangement and motion of particles in solids, liquids, and gases, very important for Unit 5. And then gas laws, very likely to appear in your exam. My suggestion for gas laws would be one of the most common mistakes that students make is they forget to convert temperature in degree Celsius to temperature in Kelvin. When it comes to gas laws, no temperature can be in degree Celsius. It has to be converted to Kelvin. This is a must. And this is where most of the students make a common mistake. Make sure you guys don't make it. Temperature in gas laws must be in Kelvin and not degree Celsius. And analyzing atmospheric pressure in certain contexts. So let's say you have a cup, you fill it up with water, you cover it up with a cardboard, and when you tilt it, as in uh, make it upside down, the water stays inside. So what is it that holds the weight of the water? There is no glue or something, right? What happens is when you fill it up with water, the water replaces the air inside the cup. Okay, so there is very little pressure inside, but a very higher pressure outside. So pressure is low here, and air pressure or atmospheric pressure is very high here. So this pressure difference creates an upward force that holds the weight of the water. So you might be asked to apply this concept in any other situation. Next, we move on to Unit 6. This is where thousands and thousands of students all around the world make a common mistake. They mix up DC motor with AC generator, which I have discussed in details in the common mistakes to avoid video as well. So let me just say it one more time because this is so important. When it comes to DC motor, you provide electricity, you provide a current, okay? You provide it with a power supply. Current flows to the coil. This creates a magnetic field. When the magnetic field around the coil interacts with the magnetic field of the permanent magnets, a force is exerted, which causes the coil to rotate. But when it comes to an AC generator, you make the coil rotate yourself. There is no current that you provide. And when you rotate the coil cuts the magnetic field lines. And what happens when the magnetic field lines are cut? A voltage is induced. So you are generating electricity in a generator, and you are generating motion or producing motion in a DC motor. Okay, so these are the two terms that I see a lot of students using interchangeably and incorrectly. So when it comes to motor, the field lines interact, and when it comes to generator, the field lines are cut. Just remember these two phrases. Then you have to be able to analyze force on a straight current carrying conductor in a magnetic field. So a dot always represents current out of the page. By the way, I did not create any of these images. These are collected from the question paper. So these are really important. So when you apply the Fleming's left-hand rule over here, what happens is current is out of the page. Current is out of the page. The dot represents current out of the page. Magnetic field north to south. So when you apply Fleming's left-hand rule, the force on it will be to the left. Applying Fleming's left-hand rule. And this, Pearson has borrowed this from A-level physics. This is the very, very, very common concept of A-level physics. So what happens is, let's say you don't know the magnetic poles, that is irrelevant, okay? But if the same concept that you applied over here, this is just in a different perspective, right? Different angle, but it's the same concept. Let's say if there is a force on the wire upward, okay, the magnets exert a force on the wire upward. Guess what? According to Newton's third law, the wire will exert a force on the magnets downward, and this will cause the reading to increase. And the opposite also holds true. If the magnets exert a force on the wire downward, according to Newton's third law, or which you don't have the third law part in details in paper 1, if there is a force on the wire downward, the force on the magnet will be upward. The reading on the balance would decrease. Then you might be asked to draw magnetic field patterns around a bar magnet and between two bar magnets. Around the bar magnet, you all know field lines flow from north to south. And one thing to note is the gap must increase gap size and field lines cannot overlap. No way the field lines can overlap. Very important. And always remember, field lines flow from north to south. And when it comes to between two magnets, and if there is a uniform magnetic field, this is north, this is south, field lines will flow from north to south. If it's a uniform, the field lines must be straight, parallel to each other, and equally spaced. These are the three requirements for a uniform magnetic field. And as always, field lines always flow from north to south. And you might be asked to describe how to produce a uniform magnetic field, again given in the fact sheet. Now we move on to unit 7, as in radioactivity. So alpha decay and beta decay equations. Okay, so when you are asked to complete the equation, my suggestion is always start with the alpha particle or the beta particle. So you know the structure of alpha, which is 4, 2. Okay, and always remember, assess the top row and bottom row separately. So 90 plus 2 is 92. So this is uranium 92. And this is 238. So what do you need over here? That when added with 4 gives you 238, because the numbers on the left hand side and the right hand side must be balanced, since you are calling it an equation, right? So the numbers must be balanced. So this has to be 234. And when you add 234 with 4, you get 238, of course. And when it comes to beta, always remember it's 0 minus 1. So 234 plus 0, you see it remains 234, no change in mass number. But when you subtract 92, when you subtract 1 from 92, this gives you 91. And this is how you balance decay equations. Next, from a setup like this, you may be asked to name the detector. Okay, so this detector is a GM tube. And this is a counter. You have to connect your GM tube to the counter. And then you might be asked the sources of background radiation. So cosmic rays from outer space, radioactive minerals present on the Earth's crust. These are all sources of background radiation. And the number one source of background radiation is actually radon gas. Okay. Then you need to be able to know the risks of radiation and safety precaution. Okay. And every time question asks a harmful effect of radiation and explain a harmful effect of radiation. So the points are radiation is ionizing, which can cause cancer. You can directly jump to cancer, or you can keep it a bit mellow and say that it can damage the DNA, it can damage the healthy cells, etc. And then you have a count rate calculation. This is very, very, very important. Check this out. Protactinium 234 decays with a half-life of 70 seconds. Initial count rate is 840 counts per second. Calculate the expected count rate after 140 seconds. So for these questions, I always ask my students to stick to a graph, which is somewhat foolproof and very less prone to errors. This is your activity. The other name for activity is count rate, by the way. The other name for activity is count rate. So activity against time. And this is your initial activity, which is 840. And it decreases exponentially like this. Always remember the half-life is 70 seconds. And again, memorize the definition of half-life and all the other definitions from the definition sheet. Half of 840 is 420. This is 420. And the time it takes for the value to half is the half-life, that is 70. And then it says, calculate the expected count rate after 140. 70 is gone, And in the next cycle, 420 divided by 2 is 210. This was already 70. 70 plus 70, this is the second half-life, is 140. And after 140 seconds, this is the count rate or activity, 210. Okay, so this, I saw this concept in an R paper. Okay, this is the original paper, but it's the same specification. So this is when I realized Pearson has been introducing concepts from A-level physics slowly but surely into IGCSEs. So this is just a contingency of mine. Okay, I wouldn't say this will appear in your exam, but this is just our plan B. So you see, this is some tracks from a cloud chamber or a bubble chamber. Okay, the thickness of the tracks are related to ionizing ability of the particles. Alpha is strongly ionizing and beta is only moderately ionizing. So alpha tracks are thick and beta tracks are thin. Okay. So this, the whole answer is actually from an A-level physics question, but I saw analyzing tracks in one of the IGCSE papers, so I just thought I had to give this. Okay, just go to this. Then you need to be able to distinguish the difference between irradiation and contamination. So this diagram should help you clarify. When it comes to irradiation, the body is only exposed to radiation. The radioactive source is not inside the body, it is outside the body. And the body does not become radioactive. And irradiation can be used for cancer radiotherapy, and it can also be used for sterilizing food. Whereas contamination is when the radioactive source itself is on or inside the body, and the body has now become radioactive, and the body will be emitting radiation. And irradiation is very easily removed. Just remove the source. It is very hard to remove the contamination, which is more dangerous. Then you have fission and fusion. Okay, I hope you all know the difference between fission and fusion and the common points regarding this. And fission is not just the splitting of nuclei, you have to apply it in the context of generating electricity. Okay, and on Earth, why uh, we have not yet been able to achieve fusion? These are also very important points. And where is fusion taking place naturally? In the core of stars. Okay? All the points again are given in the previous videos and the fact sheet. Now, the very last topic, that is astrophysics. You need to be able to distinguish the life cycle of low mass stars and massive stars. So it starts with a nebula, which is a cloud of dust and gas. It turns into a main sequence star, and then this sequence, the one on the left, is for low mass stars, and the sequence on the right is for massive stars. So after the main sequence, a low mass star turns into a red giant, a white dwarf, and eventually a black dwarf. Whereas when it comes to a massive star, it's a red supergiant, supernova explosion, and after the supernova explosion, it can either turn into a neutron star, or if it were exceptionally massive, black hole. So you need to be able to clearly know the sequence of these two events. And then orbital speed calculation. And every time you see the orbital speed calculation, remember the equation V equals 2 pi r by t, where r is the orbital radius and t is the orbital time period. And here I have seen a lot of students making mistakes with the units. Be very, very, very wary of the units. And you can see which unit you have to keep your answer in by seeing the unit given in the answer section. Okay, they'll say you have to give your answer in this specific unit. You should also know how the color of a star depends on the temperature. So in everyday life, blue represents something cool, right? But when it comes to the grand scheme of things, blue is actually very hot and red is actually the coolest. So blue stars have the highest temperature and red stars are the coolest. Then this part is also very important. Need to know the difference between the orbits of similarities and difference between orbits of planets and orbits of comets. Uh, Orbits of comets are highly elliptical with the sun at one focus, not at the center. Remember this. But when it comes to planets, it's somewhat circular with the sun at the center. And these are some of my final suggestions. Please, please, please memorize the fact sheet inside out, but only go through the Unit 1 answers. Review the experiment sheet. This will be very important for your exam. Memorize the definition sheet, which will come with the fact sheet. Review the full syllabus revision video for, sorry, this is not Unit 1, this is Paper 1, my bad. This is Paper 1. Review the full syllabus revision video for Paper 1. Watch the common mistakes to avoid video as well. And review your previous mock papers and see where you have made the mistakes. Good luck with your exam tomorrow. Do let me know how the exam goes in the comment section. Take care.